Now that you know the basics about writing XPDL rules for custom entities, we can now take it a step further and start looking at the most efficient ways of using them, by embedding rules within other rules. These embedded rules have hierarchical relationships among them, which is why we call them hierarchical rules. We also use related terminology to refer to the rules at the top level as parent rules, and the rules at the lower level, or the embedded rules, as the children rules. With parent and child rules, there are two main hierarchical structures you can come across when writing the rules. You may have parallel child rules, as you see on the left. In this case, the child rules are both under the same parent rule, so they're on the same level and operate in parallel. Or you may have embedded child rules, where you have a child rule that has its own child rule, so they're on different levels. In other words, the child rule of level 1 becomes the parent rule of the child rule in level 2. Now, why do we even need hierarchical rules? So, when we use hierarchical rules, we end up writing more efficient queries that run faster. And we're also avoiding the use of repeated queries, which are needed more than once in our rules. So it ends up being less work on our part, less queries to write. Now, for the most efficient rules possible, there are a few principles you should follow. First, you should try to make sure the parent rules are fast. What we mean by this is that we should avoid having our parent rules contain functions that hog computing resources. So we try to avoid functions like dependency, repeat, known words, and any function that requires syntactical analysis. Instead, try to use functions that are quicker for the system to process, such as simple keyword searches or even positional functions like phrase, which may be a little slower than single word searches, but they are faster than using syntactical functions. So for example, let's say you want to use a dependency function to find all the nouns that are subjects of the verb break. If you do this directly in a single rule, it will run the function dependency on every single document in your dataset, which ends up being very time-consuming. It would be much faster if you could first limit that search to only the documents you know might be talking about broken things. So running a fast function like this one on all the documents will eliminate as many records as possible. Then when you run the more time-consuming function, it doesn't have to go through as many records. Clearly, this is much, much faster. And as we just went over in the previous example, our previous rules not only need to be fast, they also need to eliminate as many unneeded documents as possible. This ensures that our more complex, time-consuming queries will run on a smaller subset of the data, and this means it won't take as long to execute. So for example, we can set up a parent-child rule where we first search for adjectives, then assign them to a named group, and finally look for a phrase with anything in that named group followed by a popular location. Now, does anyone see what's wrong with this setup? So, the problem with this hierarchy of rules is that almost every document has an adjective, so it doesn't really filter out anything. We might as well have just put the phrase at the top level. So, what's one simple thing we can do instead? Maybe instead, we first search for the term popular location, which will actually filter out plenty of results that don't even discuss the topics we're searching for. This way, you end up running the phrase function on fewer documents. And since phrase is more resource intensive than the function's term or lemma, this approach helps us speed up our node execution time. Now, one last thing to consider when optimizing parent rules is that we also want to make sure to assign named groups to queries that are repeated in our XPDL rules. Named groups are much faster than the PDL queries you'd need to write to find them, So if you're going to repeat something, it's more efficient to repeat a name group instead of writing a lot of repeating PDL. So for example, let's say we have two rules we want to use. Now, because the function unknown word is so time consuming, it seems pretty wasteful to run this twice on all our documents. Instead, we can use a parent rule to assign a frequently needed query to a named group. This means that you can use the named group anytime you need to use those pieces of text, so you only need to do the search once. Then you can use the results of that search over and over again instead of wasting time doing the same search multiple times. Okay, so let's recap the basic principles of parent rule optimization. We want our rules to be fast and efficient. So you don't want to run a time-consuming query on more documents than you need to, and you don't want to repeat the same PDL query over and over again unnecessarily. Instead, try using your top-level rule to assign several named groups that you'll use frequently in the child rules. And you can also use hierarchical rules if you simply want to break down your complicated queries into pieces that are easier to understand and edit. And finally, here's some tips to think about when you're not sure whether you need a parent rule. So, if you notice in your PDL that you have the same PDL code repeating multiple times, you might consider using a parent rule that uses a named group instead. And if you notice your node is running way too slowly, you may want to try a parent rule that narrows down the number of documents before running a more computationally intensive query. Now, let's go through some hands-on practice with writing hierarchical XPDL rules and creating custom entities. In this hands-on practice, we're working with a dataset of car repair service records that contains written notes of the issues, the affected car parts, and the recommended repairs. And we're going to play again with finding and extracting car issues, but this time we'll do it a bit more efficiently. Let's start by going into the node. Now, we see that we're extracting phrases and words from the text that indicate issues, like broken or defective. But what if we want to extract more information, such as the car part that's related to the issue? So let's add a little more to this rule, which we already have in place for finding and extracting the issues. Now, we want to add to this rule, so a way to find the car part associated with the issue. And we want polyanalysts to extract whatever noun or noun phrase is being referred to when we find words or phrases indicating an issue. So, should this additional XPDL be part of the parent rule, or should it be a child rule in this case? Remember, our goal is to have our rules be fast and eliminate as many unneeded documents as possible. So, in this case, it's more efficient to create this new rule as a child rule. Think of it this way. If we search for issues and parts in the same parent rule, this takes a lot more time to process, since the system is looking at every document and performing both these tasks. But if we're first filtering out documents that contain words that signal an issue, and eliminating documents that don't contain any issues, then we're running the second task of finding the car parts on fewer documents. And oftentimes, these records might, for example, mention parts without being linked to an issue, such as routine part replacements that are part of general vehicle maintenance. And this is more of a reason why we should first filter documents by whether we found an issue. And in the end, this child rule approach is more efficient and ultimately speeds up the node execution. So let's start writing our child rule. We'll call this child rule issue with part, and we'll add the following query that finds noun phrases that are near an issue. And we'll match this as the fault phrase. Then in our result block, we can extract the issue and the part as separate attributes. Okay, now we can check our syntax to make sure this rule is written properly. And now that the rule syntax seems okay, let's test some sentences in our test panel to see if we're capturing things properly. Okay, now that we've tested our rules and they work, let's re-execute the node and check our results. And if we open this node now, we see in our results that we have our columns for our match, as well as the issue and the part. Now, let's take a step back and assess our rules and see if we hit our optimization checklist. So, first, is our parent rule as fast and efficient as it can be? Yes. The parent rule is using single words or positional functions instead of a more computationally intensive function. Second, is our parent rule eliminating as many unneeded documents as possible? Yes. Our parent rule is first removing documents that don't contain an issue before our child rule for extracting parts would be applied. Third, is our parent rule assigning frequently used PDL to named groups? Yes. Our parent rule creates the named group issue, which is used in our child rule instead of writing out the same query again. And this concludes the hands-on portion of this topic. In the next topic, we'll go over some best practices for working within the entity extraction node, as well as some helpful tips and tricks for building custom entities.